Hello students, welcome to BioSTEM Academy. In this lesson, we are going into one of the most misunderstood but extremely important topic in JAMB and WAEC mathematics. This topic is sorts. By the end of this lesson, you will understand definition of sorts, properties of sorts, how to simplify sorts, how to add and subtract sorts, how to multiply sorts, how to divide sorts, how to rationalize denominators, and if time permits, we are also going to look at how to solve real JAMB and WAEC style questions. Let's dive right into the isagogy of today's lesson. Definition of sorts. Definition of sorts. Now, according to textbooks and other sources, irrational numbers are called sorts. Irrational numbers are called sorts. A sort is a number that cannot be expressed exactly as a fraction. Numbers which cannot be expressed exactly as fractions are called sorts. Example of these numbers are, for instance, root 2, root 3, root 5, root 7, root 11, root 13, etc. So if you look at these numbers, they cannot be expressed exactly as a fraction in form of a over b, for instance. These numbers are non-terminating and non-recurring decimals, meaning they continue forever without pattern. The opposite of sorts is rational number. Opposite of sorts are rational numbers. And we know that rational numbers are numbers of the form a over b. So whenever you hear sorts, what first comes to your mind is irrational numbers. So this is all our sort. If the opposite of irrational number is rational numbers. Rational numbers. Now, properties of sorts. Properties of sorts. Property 1 or rule 1 is sort can be added, subtracted, or multiplied. Sorts can be added, they can be added, subtracted, or multiplied. Example, A would be plus C would be. This gives us A plus C would be. Note that you only add or subtract sorts with the same or similar roots. For instance, 2 root 3 plus 4 root 3. 2 root 3 plus 4 root 3. The roots are similar, so go ahead and add them. 2 plus 4. 2 plus 4. Then take only one root, 3. Then 2 plus 4 is 6 root 3. Right? However, if the roots are not similar or are not the same, in this situation or circumstance, we don't add or subtract the sort. For example, 2 root 3 plus 5 root 7. So 2 root 3 plus 5 root 7. The roots are not similar, so we're going to leave them like that. Right? Now, and rule 2, property 2 is root A root A times root B, and this is equal to root A times B, which is equal to root AB, right? Property 3 or root 3 is root A over B. This root A over B is root of A all over root of B, and this is the same thing as root AB over root B. So we'll understand this more when we come to examples section. Now addition and subtraction of sorts. Root of 7 plus root of 3, this I like it, minus root of 7 minus root of 3. And the first thing is for us to clear the brackets or remove brackets. And then when removing the brackets, we have root 7 plus root 3 minus times plus here is minus 7 minus times minus is plus with 3, right? Then the next thing is collect like terms. But by collecting like terms, we have root 7 minus root 7 plus root 3 plus root 3. So root 7 minus 7 is 0. Root 3 plus root 3 is 2 root 3. That means 1 root 3 plus 1 root 3 is 2 root 3. Right? B, we have 5 root 2 minus 3 root 2 plus root of 2. Right? So here 5 root 2 minus 3 root 2 plus 2 plus root of 2. Now we do what is called, we follow the rule of BODMAS, right? Follow the rule of BODMAS. Brackets of division, multiplication, addition, then subtraction. So addition comes first before subtraction. So you go ahead and 5 root 2, instead of writing minus 3 root 2, just go to plus root 2, and finally minus 3 root 2, right? So 5 root 2 plus root 2 is the same thing as 5 root 2 plus 1 root 2, right? And this gives us 6 root 2 minus 3 root 2. So root of 2, if you look at these roots are similar, so subtract this minus 3 is 3 root 2. So this is the final answer. Now C, then we have to simplify or evaluate 243 root 2, 243 plus root 75, then minus root 1 over 3, right? Minus root 1 over 3. Here, this 243 are going to simplify it because 3 can go into 243. Yes, 3 can go into 243 because 243 over 3, 3 here 1, 3 into 24, 8, 3 here 1, 3 into 3, 1, so 83, right? 81. Therefore 81 times 3, and 81 is the rational number. It's a rational number. So plus root 75 can be split into 25 times 3, and then minus root 1 over 3, right? So root of 81 is 9. Therefore 9 root 3 plus root of 25 is 5. 5 root 3, right? Then minus root 1 over root 3, root 1 over 3. So in this, if you look at this one, particularly this root of 1 over 3, is, if you can remember, just like the same property 3, which says root 1 root a over b is the same thing as root a b over b, right? So it's the same thing as root 1 times 3 over 3. That is root 3 over 3, right? This root is here, right? Now, but how do we do this? We rationalize root 1 over 3 with the same thing as root of 1 all over root of 3, right? Then is equal to root 1 is 1 over root 3. So our denominator is having roots. So we carry out what is called rationalization. And rationalization is the act of you removing these roots. In the process of removing roots in the denominator of a given sort. This is all about rationalization. And you do that by multiplying top and bottom by this conjugate times root 3 all over root 3. And 1 times root 3 is root 3. Then root 3 times 3 is 3. Or if you like, root 3 times 3 is root 9. Root 9 is root 3. So see, you're back here, right? So now, taking this from this step, 9 root 3 plus 5 root 3 minus. Now this one is all about this. Root 3 over 3, right? So 9 root 3 plus 5 root 3. The answer is 14 root 3 minus root 3 over 3, right? So we can go ahead and this is a fraction, right? So 14 root 3, 14 root 3 minus root 3 over 3. So this is over 1. LCM of 1 and 3 is 3. 3 divided by 1 is 3 times 14 is going to be 42 root 3 minus 3 divided by 3 is 1 times root 3 is root 3, right? Therefore, 42 root 3 minus root 3 is the same thing as 41 root 3. Why? Because this is 1. 42 root 3 minus 1 root 3 original. So that is why we will left with only 41 root 3 over 3. That's the final answer for this. So now multiplication of sorts. Multiplication of sorts. Example, simplify root 7 plus root 3 into root 7 plus root 3, for instance, right? So what I'm going to do, just like when you have brackets, algebraic expressions, this root 7 times root 7, the answer is 7, right? And plus root 7 times root 3, the answer is root 21. And done with this. Next is root 3 times root 7 is plus root 21, and this is plus times plus is plus. Root 3 times root 3 is 3. Therefore, 7 plus root 21 plus root 21 is 2 root 21 and plus 3. So you can add this 10, right? Plus 2 root 21. We can stop here. Oh, yeah. 10 plus 2 roots, 21. Now, rationalization of sorts. So rationalization simply means the process or the act of removing the roots of a given sort in the denominator. For example, this rule 4, a over b, which is equal to root of a all over root of b, and which is the same as root ab over b. So generally, we don't supposed to leave the answer of a given sort or the sort, especially in the denominator, with a root. So we have to find a way of eliminating the roots, and this is called rationalization. Now examples. Example A, let's say rationalize the following. A 1 over root of 3 plus 1, B 9 root 6 plus 2 root 3, and all over 3 plus root of 2. Now solution. The first one, 1 over root of 3 plus 1. So if you actually rationalize this question, 1 over root of 3 plus 1, the first thing in rationalization, how do you remove this, is by multiplying the numerator and denominator. This is the numerator while this is the denominator. So we multiply numerator and denominator by the conjugate of this. Conjugate is root of 3. Instead of you to write plus, then you write minus. Why? Because you're taking the conjugate of this. 1 all over root of 3 minus 1. Okay, this is the conjugate of this denominator. Then this process is called rationalization. So 1 times root 3 minus 1 is root 3 minus 1. Is that understood? Yes. All over root of 3 times root of 3, the answer is 3. Or root of 9 is 3. Then this and this. Root 3 times minus 1 is minus root 3. Then plus 1 times root 3, this and this is plus root of 3, right? Then plus times minus is minus. 1 times 1, 1, right? Therefore, root of 3, our numerator, minus 1 all over minus root 3 plus root 3 will give us 0, right? Then 3 minus 1, 2. Therefore, root 3 minus 1 over 2 is the same as 1 over 2 into root 3 minus 1. And this is the final answer, right? Now B is 9 root 6 plus 2 root 3 all over 3 plus root of 2. So by rationalizing, we say that this question 9 root 6 plus 2 root 3 over 3 plus root of 2. Now how do we rationalize this? By multiplying the numerator and denominator of this sort by its conjugate, the conjugate meaning the denominator, right? Conjugate of denominator, then times 3 minus root of 2 all over 3 minus root of 2. So 9 times 3 is going to give us 27. Root 6, 27. Then attach root 6 because 9 times 3, 27, and attach root 6 to it. Okay. The next is plus CA minus CA. Then plus minus is minus. 9 times 1 here is 9. Then root 6 times 2. Just put them inside square root. This times 2, 12. Then you're done with this and this. Then plus times plus is plus 2 times 3. Since they are both integers, 2 times 3, 6. Root what? 3. Right? And plus times minus is going to give us minus. Then this is what? 2. Then this is root 3 times root 2 is root 6. 2 times 3 or 3 times 2 gives us 6 inside root. I'm done with this numerator. Now the denominator, 3 times 3 will give us 9 plus times minus is minus 3 times root 2 is 3 root 2 and plus times plus is plus root 2 times 3 is 3 first then root 2, right? And plus times minus is going to give us minus. Root 2 times 2 is 2, or root 2 times 2 is 4, root 4 and root 4 is 2, right? Then here 527 root 6 and minus 9 root 12. We can split it. You can simplify this root 12 as 4 times 3. Then plus, we write everything here. 6 root 3 minus 2 root 6. Right? And all over minus 3 root 2 plus 3 root 2 is 0. Cancel each other. Then 9 minus what? 2. Therefore, 27 root 6 minus, this is 9. Root of 4. Root 4 is 2. So 9 times 2, root 3 plus 6, root 3 minus 2, root what? 6. All over, this one cancel, all over 9 minus 2. 9 minus 2 is 7. Right? Therefore, 27 root 6 minus 9 times 2 is 18. Root 3 plus 6 root 3 minus 2 root 6 all over what? 7. Right? Now root 6 is here, root 6 is here, root 3 is here, root 3 is here. So the next thing is to collect like what? Like terms. Shared form is called this, collect like terms. Therefore 27 root 6, then jump this because there is no root 6, jump this, there is no root 6, and then come here, minus 2 root 6, minus 2 root 6, and go back, minus 18 root 3, minus 18 root 3, and this plus 6 root 3 plus 6 root 3 all over 7. So 27 root 6 minus 2 root 6, 27 minus 2 is going to give us 25 root 6. Then minus 18 root 3 plus 6 root 3, just minus 18 plus 6 is minus 12, right? Root what? 3 all over 7, right? So we're going to, the next step is 1 over 7 into everything here. Copy the numerator of this sort, 25 root 6 minus 12 root what? 3. And that is reduced to its final steps. So C, the C is 2 root 5 minus 7 root 2 all over 3 root 7 minus 2 root 3. Now, in order to waste time, just multiply this by its conjugate, rationalize. By rationalizing, we have times, copy this, 3 root 7. Instead we write minus, this time we write plus 2 root 3, right? Over, copy it again, 3 root 7 plus 2 root 3. Now, even if we do it fast, I think we are now following. Since we've done first one A, B, even the last one has to be, we have to do it in a hurry, and I don't think there will be a problem, right? Then 2 times 3 is 6. Root 5 times root 7 is root 35, right? Then plus is plus, 2 times 2 is 4, root 5 times 3 is 15, right? Then minus times plus is minus, 7 times 3 21, root 2 times 7 14, right? Minus plus is minus, 7 times 2 14, root 2 times 3 is 6, right? Then 3 times 3 is what? 3 times 3 is 9. Root 7 times 7 is 7. Or root 49, and root 49 is 7. Then plus times plus is plus. 3 times 2 is 6. Root 7 times root 3 is root 21. Right? Then minus plus is minus. 2 times 3 is 6. Root 3 times root 7 is root 21. Right? I done with this. Minus plus is minus. 2 times 2, 4. Root 3 times root 3 is 3. Now we're going to copy 6 root 35 plus 4 root 15 minus 21 root 14 minus 14 root 6 and all over 9 times 7 plus 6 root 21 minus 6 root 21 minus 4 times 3. So numerator 6 root 35 plus 4 root 15 minus 21 root 14, then minus 14 root 6 all over 9 times 7 63. 9 times 7 63. 63 plus 6 root 21 minus 6 21, this is 0. 4 times 3 is what? 4 times 3 is 12, right? Then copy this numerator 6 root 35 plus 4 root 15 minus 21 root 14 minus 14 root 6 over 63 minus 12. 60 minus 10 is going to be 50, and 53 here, we remove 1, 2 is going to be 51, right? Because 51 plus 12 is 63. Then 6 root 35 plus 4 15 minus 21, 14 minus 14 with 6 all over 51, right? So this cannot be rationalized, cannot be simplified further, this cannot be simplified further, this cannot be simplified further, this cannot be simplified further. So we can leave them like that and then just write 1 over 51 into 6 root 35 plus 4 root 15 minus 21 root 14 and then minus 14 root 6. This is the end of the video. And that's how simple sorts are when you understand them. If this helps you, like the video, subscribe and to WAEC Academy and share. Subscribe so that whenever a new video is uploaded, you get notified instantly. Thank you for watching.